Solving systems using inverse matrices part 2. So it's example A2 and A3. Okay, so first I need to find the coefficient matrix. I'm looking at A2 and it's out of order. I need the X's and Y's to be on the left-hand side and then the answer to be on the right. So all I would need to do is add 3x to both sides. If I add 3x, I add 3x, and then I can write that as 3x. It was a positive 3x, it was a positive y, and the only thing left on the right would be the 2. Okay, now that's in order. I have my x's and my y's, and then on the right-hand side, I have my answer. So my original coefficient matrix would be 3, and that coefficient for y would be a 1, 6, and 2. Okay, so that's the original A. I know I need to find the inverse of A so that I can multiply it by my answer matrix, my B, which would be the 2 and the 1. So if I want to find the inverse, I need to multiply the first diagonal, which would be 3 times 2, and that would give me 6. Because first I need to find the determinant, right? So 6, and then I'll multiply the second diagonal, 6 times 1, which is also 6. And I have to remember I'm always supposed to subtract these two. Now 6 minus 6 gives me a determinant of 0. And you do recall that if your determinant is 0, you cannot find the inverse matrix because the formula for the inverse matrix is supposed to be 1 over the determinant, right? But I cannot have a 0 in the denominator. So because I cannot divide by 0, then I do not have an inverse matrix. And if I do not have an inverse matrix, then I do not have a solution. No solution. Remember again, these were straight lines, and we talked about this yesterday. If there was no solution, then these were really just two different equations, well, for lines with the same slopes, right? These lines never crossed. They were parallel lines. And that is why there is no solution. So if you get a determinant of 0, then there is no solution. You can't go on any farther. Okay, let's move on to number 3. So this is out of order as well. You may recognize this problem. I asked you yesterday to solve it with substitution and elimination. But today we're going to do it using matrices. Again, I need my x's and my y's on the same side. So I need to rearrange this bottom one. I will subtract y. And what that will give me is the positive x, take away the y, and there was nothing left on the right-hand side, so it's a 0. Okay, so my coefficient matrix, the original A, would be the 5 and the negative 6, 5 and the negative 6, and 1 and negative 1, 1 and negative 1. Again, the x's should always be first, and the y's should always be second. So let's find the determinant of this. 5 times negative 1 is negative 5, and product of the second diagonal, negative 6 times 1 is negative 6. But I must remember, I'm always supposed to subtract these two. And when I end up subtracting a negative, that's actually going to be a plus. So what is negative 5 plus 6? Negative 5 plus 6 is just 1. So my determinant is 1. It's going to make things easy. Because again, the formula to find the inverse is 1 over the determinant, which is 1. And then I wanted to switch the main line. So I want to switch the 5 and negative 1. So that will be a negative 1 here and a 5 here. The other two numbers stayed put, but they were the opposite signs. So this is actually going to be a positive 6, and this is actually going to be a negative 1. All right, and now all I had to do was multiply this, scalar multiplication, by everything in here. Well, it's just a 1. A 1 over 1 is just a 1, so it's not really going to change anything. My inverse matrix is simply going to be negative 1, positive 6, negative 1, 5. That is the inverse matrix. And when I am solving using matrices, I wanted to take that inverse matrix and multiply it by my answer matrix. My answers, let's see, were negative 4 and 0. That was what was on the right-hand side of the equal sign. So my B is what they called it, was negative 4 and 0. Okay, so I will just do matrix multiplication across and down to find my answer, which will give me my x coordinate and my y coordinate. So across and down, each one has its own partner. So the negative 6 multiplies with the negative 4. That's going to give me a positive 4. And the 6 is going to multiply with a 0. That's going to give me a 0. And of course, we always add. All right, that was it for the first row in the first column. So now the second row goes down that first column. The negative 1 multiplies with the negative 4 and gives me positive 4. The 5 multiplies with the 0 and gives me 0. And of course, we add. Well, 4 plus 0 is just 4. And 4 plus 0 is just 4. So, again, remember the top number was my x, the second number was my y. It doesn't matter really this time because they're both 4. My answer is 4, 4. We got it? So there are 2 stars for you to do. I will send it to your Google Classroom.